At 11:27 a.m. local time on June 16th, a strong magnitude 6.7 earthquake struck Indonesia's island of Sulawesi. As ground shaking was subsequently felt over a large area home to 17 million people, landslides were triggered, multiple homes collapsed, and at least 400 additional structures were damaged. Only one fatality has been confirmed so far, along with more than a dozen injuries, although median U.S. Geological Survey models suggest $16.59 million in damage and 9 fatalities may have occurred. Honestly, this earthquake could have been a lot worse given its magnitude, epicenter fairly close to populated areas, and shallow depth that it struck at. In my opinion, I think the number of casualties would have at least been double or triple if this earthquake had instead occurred at night rather than just before noon, when a low number of people were inside various structures. The June 16, 2026 earthquake did not occur on one of the region's multiple nearby tectonic plate boundaries, but rather on a large local fault line known as the Sausu Fault, which runs for around 33.7 kilometers or 20.9 miles. Due to extensional forces which cause stress to build up and then be released, a large earthquake was triggered on this normal fault. I estimate that between 25.3 kilometers and 29.5 kilometers of this fault line slipped during Tuesday's earthquake, meaning this event may have represented close to the maximum earthquake magnitude the Sausu Fault can theoretically produce. Which, if we go purely based on a simple mathematical model, the largest earthquake this fault line, in my opinion, could be capable of generating is a magnitude 6.88. This isn't the first time a larger magnitude earthquake has occurred close to or on the Sausu Fault, as it has been the site of 4 lower magnitude 5 range earthquakes in the last 50 years, and in addition, a strong magnitude 6.6 quake struck vaguely close to it on May 29, 2017. Regardless, this truly was the largest known earthquake to have specifically originated on the Sausu Fault line in historical times. Already, multiple aftershocks have struck in the vicinity, mostly between the Sausu Fault and nearby Pablo Fault. 3 of these aftershocks were between magnitude 4.8 and 4.9, while 3 aftershocks were between magnitude 5.0 and 5.2. More aftershocks are likely to strike in the upcoming days, but these should decrease in abundance as time since the main shock earthquake increases. It is true that this earthquake did occur in close proximity to a tectonic plate boundary, specifically the boundary of the Molucca Sea and Banda Sea plates, but the largely strike-slip motion of this boundary could have easily placed strain on the Sausu Fault to generate this week's earthquake. Both landslides and liquefaction were modeled to have had a chance of occurring in multiple areas due to the magnitude 6.7 earthquake, but I have not been able to yet confirm how accurate these models are in comparison to actual on-the-ground observations. If you are wondering, no, this earthquake shouldn't even have a remote chance of triggering some form of activity at any of the region's volcanoes, and by volcanoes I actually mean one volcano, the Colo volcano. As the closest active volcano, it experienced only MMI 3.5 shaking, and at least MMI 5 shaking is needed to have a chance of triggering some form of activity in my opinion. As a final note, I would like to thank my new patron Sally Wiener for supporting my work.